So, hello everyone. We'll be starting a new course, which is Irrigation Engineering. Irrigation Engineering. So, in Irrigation Engineering, the first topic or the first chapter that we are going to discuss is theories of seepage. Theories of seepage. Okay. So this chapter is one of the important chapters in not only in the irrigation engineering, but also if you see the soil mechanics, it's really important chapter. We need to get hold on to the chapter. Okay, this theories of seepage. First, we need to understand that whenever we design any structure, to design any structure, first we need to develop its or we need to form its foundation. So every structure needs a foundation. Let's just say we are designing a dam on this hydraulic. So this is a hydraulic structure, or simply we can say dam or hydraulic structure. And this is your foundation. So there are two ways that this hydraulic structure will experience the pressure, and this hydraulic structure may fail. So the two ways. First is it may fail above the surface. Let's say this is your surface. It may fail above the surface, or it can fail below the surface. Below the surface. So there are two ways it may fail. So first we will see how it can fail below the surface. Okay. See, when the water it percolates down the foundation here, and if this foundation is impervious, so there is no way out for this water to go. So what it will do, it will develop the uplift pressure, or we can say it will develop the hydrodynamic pressure below the base of this foundation. So this is the basic concept how it will fail below the surface. When this uplift will exceed the the counterbalancing force which are acting on this foundation. So what are the counterbalancing forces? The forces which are trying to, you know, withhold this hydraulic structure. Say its weight, mg. So its weight acts as a counterbalance to the uplift. And the two ways, we will discuss the two ways how this uh, the subsurface failure occurs. The first failure is the uplift pressure. Okay, uplift pressure. See, the mechanism is the same in uplift. How this occurs. When the water percolates down the foundation and will exert an uplift force on the base of the foundation, and it will be counter reacted by the weight of the foundation or weight of the superstructure, both foundation and superstructure. Now the first and the foremost thing is for a designer is to design this foundation and hydraulic structure in such a fashion that it will counter react the uplift pressure. So how we can counter react this uplift pressure? The first thing is by increasing the thickness of the foundation. So if you will increase the thickness of the foundation, what will happen is it will lead to the increase of that load. So its dead load will be increased. So this is your foundation, this is your say any hydraulic structure. So this is your uplift pressure and your weight mg. So this mg weight, it should be greater or equal to your uplift pressure. If it's greater or equal to your uplift pressure, then your structure is safe. So this is a one way to prevent this uplift pressure. And the second way is by providing so providing the sheet pile, or we can say cut off at the upper stream side. So focus on this. Why I wrote here upper stream side? Why not downstream side or intermediate side? Let's understand this. So let's just say this is your base and this is your any hydraulic structure. Okay. And you provided the sheet pile wall. I don't need to go into details about the sheet pile wall because you have already read about the sheet pile walls in the soil mechanics. So we will just see its application here, in preventing the uplift. So let's just say this is the water profile. Okay. This is your water profile. Because the uplift will be most prominent at the upper stream side. So what we need to do, we need to reduce that pressure. How we will reduce that pressure is by providing the sheet pile wall at the upper stream side. If we provide the sheet pile wall, it will have the lot of distance to travel. That will be that will reduce that will reduce its momentum, which will lead to energy reduction and which will lead to reduction in uplift. All right, to reduction in uplift. Now, what if the designer is not often, well-minded, and he provided the sheet pile wall at an intermediate level? So its water profile will be like this. So as you can see here, because the water uplift pressure is much more at the upper stream side, so there will be no point of providing the sheet pile wall at the intermediate level, because the damage that it can cause initially, you know, if the damage has been done, so what's the point of now providing the sheet pile wall? And another, which is the worst case scenario, is providing the sheet pile wall at the end. So if we draw its water profile, it will be like this. So this is the worst case scenario. So this is the worst case scenario. Okay, we need to avoid by providing this sheet pile water downstream. So these were the two, measures how we can prevent the uplift force. So this was all about the failure due to the uplift. And further in next class we'll be discussing over the the piping failure, which is the another subsurface failure.